Okay, next I want to talk about Klein bottles. So there are or three, I think, actually kinds of Klein bottles. You learned about this one already. This is the right twisting Klein bottle, which is a figure eight that is revolving around a circle and rotating as it goes. And that one can be modeled with this parametric equation. But I want to teach you about the other kind, which is the more familiar kind, or the mirror-symmetric kind. And this kind is what happens if you imagine taking a Mobius band and taking a series of them and sewing them together. And that's what makes this familiar bottle shape. Okay, so in order to make the Klein bottle, what you need is a curve that intersects itself, okay, and changes direction. So if I just mark a point along this curve, I can draw a curve like this. Having those 2 points assures that this is tangent to that. 2 points along this line. So when I draw this point and that point, it assures that it's tangent here. Then I can draw the rest of the curve, and then I can finish in the same spot. Okay, so now I know it's tangent to the same direction at the bottom. So if I split this curve, just split it there and somewhere else a little earlier, like that, and then I can take this and I can type it 30, maybe, oops, 30, 11. Okay. And sometimes this will screw up at the bottom because there'll be an extra control point because it didn't split. And I'll have to look in at this curve, select a control point, and delete one of them. But sometimes it's fine, like it is now. Okay, so 30, 11, like that. And then this has caps on it, so I'm going to delete those caps. Through it. Okay. And now, in order to connect this smoothly, I need to align it with this end of the surface and this end of the surface. I'm going to make a loft that connects this. So I'm going to get three profiles from this side and three profiles from this side. And then I'm going to split this surface with that profile and this surface with this profile. Okay, and what that does is if I have three control points, if I have a curve with three control points that are the same, it I make a curve and I make two control points or aligned with the tangent, it's going to be tangent. If I make three, it's going to be completely smooth. So this is the same principle, but in 3D, there's three curves that are originally part of this surface and three curves that are originally part of that surface. So if I make a new surface and they share those three curves, it'll be smoothly continuous. So then I'm going to add a few extra curves of my own just to finish the surface. And then what I remembered is if I just type loft and then I select these curves after I type loft in the appropriate order, it'll make the correct loft. So I can just do that, uh, and it'll loft them together. Okay. And then if I put this on rendered mode in a transparent surface, it's connected to itself. Okay, now if I wasn't happy with this, the way this shape looks, I could try rebuilding it. But then it's not going to be smooth anymore. Try 6, okay. And so I could try a match surface like that. But then if I match surface on the other side, it's going to do something weird. It's going to twist itself. And that is because, let me build this one more. Okay, that is because um, if I take the two end profiles here and move them off of each other, and I do curve start and curve start, you can see the start of the profiles on opposite sides. So I can do this command called surface seam to align the seams of the surface, and then I can match surface. And then for this, I would have to do surface seam, match surface. Okay, but typically I wouldn't probably rebuild it because you can see it's making the shape messed up. I just did that to show you the surface seam scheme. If I was unhappy with the shape, the more likely thing that I would do is, extract different curves. Or add more curves to control it and make a different loft. And then the last thing I want to point out is if I extract the isocurves, this, even though this looks like a single continuous surface, actually made it of two. So when I extract the isocurves in the other direction, I need to get both. And because it's a non-orientable surface, they sort of go around in a loop like that. Okay, that's how you make the Klein bottle. And you could again make this in many different shapes with many, many different proportions by the same principle.